Okay, so determine the resistance of 1200 meters of copper cable having a diameter of 12 millimeters. If the resistivity of the copper is 1.7 times 10 raised to the power negative 8. You are once again welcome, and please make sure you subscribe to my channel. So we are to determine the resistance of 1200 meters of copper cable having a diameter of 12 millimeters. If the resistivity of the copper is 1.7 times 10 raised to the power negative 8 ohm meter. Okay, so let's move on with the solution. We have our data. So length L is equal to 1200 meters. Then our diameter D equals 12 millimeters. Then our resistivity rho equals 1.7 times 10 raised to the power negative 8 ohm meter. So resistance R, which we don't know, so we are to determine the resistance R, or we are to solve for R, which is the resistance. Okay, so let's start with the solution. So first of all, we have to solve for the cross-sectional area, and we use the formula A equals pi r square. Pi is constant, which is 3.142. R is the radius. Okay, so we have A equals pi r square. And from our question, we were not given R, which is the radius, but rather we were given diameter. Okay, so we use our diameter to solve for R, which is the radius. Okay, so D, which is the diameter, is equal to 2R, that is twice the radius, or 2 times the radius. So to get R, we divide both sides by 2. So we have D divided by 2, then 2R also divided by 2. So 2 cancels out. Okay, so our R is going to be D over 2. So D is what? 12 divided by 2, which is equal to 6. So now our R, which is the radius, is equal to what? 6. Alright, so back to our formula, which is A equals pi r square. Now we have calculated for R, which is what? 6. So we have pi, which is 3.142 times our radius that we calculated, which is 6 square. I hope you are following it. Okay, so 3.142 times 6 square will give us 113.112 millimeter squared, which can also be written as 113.112 times 10 raised to the power 6 minus 6, or negative 6, which represents milli, then meter squared. So 113.112 millimeter squared is equal to 113.112 times 10 raised to the power negative 6 meter squared. So now our cross-sectional area has been calculated, which is 113.112 times 10 raised to the power negative 6 meter squared. Okay, So since we have our cross-sectional area now, we can calculate for our R, which is the resistance, and we use the formula R equals rho L over area. R is the resistance, rho is the resistivity, L is the length, and then A is the cross-sectional area. So let's substitute the values. So we have 1.7 times 10 raised to the power negative 8, which is rho, the resistivity, multiplied by 1200, which is L, that is the length, all over 113, that is 113.112 times 10 raised to the power negative 6, which is our cross-sectional area. So when you multiply 1.7 times 10 raised to the power negative 8 by 1200, we are going to get 2.04 times 10 raised to the power negative 5, all over 113.112 times 10 raised to the power negative 6. Okay, so when you divide 2.04 times 10 raised to the power negative 5 by 113.112 times 10 raised to the power negative 6, when you divide, our answer is going to be 0.180 ohms, which is our resistance. Okay, so our resistance now is 0.180 ohms. Thanks so much for watching.